All right, so let's talk about how to graph these other functions. Today, we're going to start off with three basic ones. Okay? So here we go. I'll tell you what. Let's do this. Let me grab this graph. Let's copy it. Let's paste it. Let's make it a little bit bigger so we can see it. All right. Well, you don't have to draw all the lines on here. If you want to use graph paper, you can. You don't have to. You could just do this, and then just put your little marks on here. I hope you're paying attention. Okay. Yeah, it might be inaccurate, but I actually just took these notes last period during my free period because I didn't realize I was going to teach this until today. So anyway, but I took my notes and I actually took a ruler and I measured it out pretty precise, relatively precise. Okay, I actually used a ruler for that. If you don't want to use a ruler, you don't have to. On a quiz or a test, I still got a lot of talking while I'm talking. I don't get that. Let me teach, please. Just let me teach. So I used a ruler. You don't have to use a ruler, but on a quiz or a test, if I ask you to graph something, I will actually give you something that looks like this on the graph, on the paper, on the quiz or on the test, okay, on the answer sheets for the test. I'll actually give you something like this to make it a little nicer, a little easier for you, all right? So I'm going to use this. It just makes it kind of nice. So let's do the first one. The first one, actually, we're so used to writing y equals something. But what did we just learn recently? We learned functions, right? So instead of y, we're going to use f of x. So that's what we're going to use, all right? Now, this is nonlinear, all right? So this is the first one. It's y equals, or f of x equals x squared. So where do we even start with that? I don't have a y-intercept. I don't have a slope. I got a squared in there. So this is not y equals mx plus b. Y equals mx plus b is linear. It's a straight line. This is not linear, okay? This looks a little different. So we could put it on Desmos. We don't have enough time because I'm running out of time already. But what we're going to do is go back to when we were in either pre-algebra or algebra 1, and we're going to do a little chart, okay? And that's a good way to start doing these. Even these are a little more complicated than we're used to. We're going to do a little chart. So usually you'd have x and a y, but now we've grown up a little bit and we're going to use f of x instead of y. So we're going to put some numbers in here, okay? You can put any numbers in you want for x and then figure out what the y is going to be. Now, since my graph is relatively small, I'm not going to put in crazy big numbers because what am I going to have to do to that x? I'm going to have to do what to the x? I got to substitute it in, right? But what do I have to do to it? Once I put a number in for that, I've got to square it, right? So I'm not going to put real big numbers in there because if I start squaring, those numbers get really big really quick. All right, so I'll stay relatively small. So let's go -2. Let's go -1. Let's put 0. Let's put 1 and 2. All right, those will keep us, fairly, easy to see kind of things. I think, I don't think I have enough. 1, 2, 3, 4, 5, 6, 7, 8. That goes 8. Tell you what, let's throw in a 3 as well. I'll give you some room. This only goes to 8, but we can just go one above it to get to 9. We'll see. So I'll go -3 and I'll go +3. All right, everybody good? So what we're going to do is just chuck this in. Let's do it really quick. If I put -3 and I'm squaring -3, so I'm not going to get a -9. So if I put a -3 in there, I get a +9. Put a -2 in for there, I get a 4. -1, I get a what? 1. Put a 0 in. 0 squared is what? 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. So what I'm going to do is I'm going to graph those numbers. I'm going to put those numbers in here. When we did linear stuff, all you needed were 2 points. But with this stuff, you're going to need quite a few. You need quite a few points to see what your graph's going to end up looking like. If I just put 2 points in there, there's no way I could figure out that my graph's going to look like it's supposed to look. So let's do that. Let's start with the 0 first. 0, 0. Okay? And let's put the positives in there. Okay, 1, 1. 2, what? 4. Automatically, you see they're not going to line up nice straight, are they? So let's put one more in there. Let's put 3 and 9. This goes to 8, so we'll go right there, okay? Now, look at the negatives. The negatives are going to be the same, basically the mirror image, isn't it? If I go -1, I go up what? +1. Put in a -2, I get +4. Put in a -3, I get +9. So now you got a good idea what this graph's going to be like, okay? You need to put enough points in there to get a general idea what it's going to be like. I don't need to put a 4 in there because that would be all the way up to 16. Put a 5, it would be way up here to 25. But this is enough to get us going. So sometimes with this graphing tablet thing, it's a little slippery and it doesn't hold very well. There we go. That's not too bad. All right, and that's basically what your graph looks like. You can always put it onto a graphing app, use that Desmos. It'll be nice and smooth, nice and pretty, but that's what it looks like. What if they ask for the domain of this thing? The domain are the x values. What x values are included on this graph? Yeah, but I could keep going to 4, to 5, to 6, to 7. I could keep going, and I could keep going this way. So what's my... It would be infinity. It would be negative infinity to what? To positive infinity. Because I can pick any x values at all, couldn't I? I could go down to a -100 and stick it in and square it. Is there any number that I cannot square? No. I could square any number, right? So it's negative infinity to infinity. But what about the range? The range is the y value. Stops at 0, or you could say it starts at 0, right? It starts at 0, right? And it goes where? Infinity. The y values, right? It keeps on going up and up. Are there any y values in the negatives at all? No, so that we don't go to negative infinity. Because when you square something, you can never get a negative number, can you? All right, when you square something, you only get positive numbers. So this goes from 0 to what? Infinity. And actually, if I wanted to do that, it would be a little bracket because it does include 0, doesn't it? Yes. All right, and then I put a, like that. You could put the brackets, you could not put the brackets. So again, the range is talking about the up and down, the y values. Look, there are no y values at all. Okay, negative, I should say this. There are y values, but there are no negative y values. There's only what? Positive y values, and there's also 0. So I include 0, and I include everything above 0. That's what that thing means right there. That's your domain and range. Let's do another one real quick. All right, so that's your first nonlinear graph. Did you do any of that in Algebra 2? Yes. Good. Yeah, it's definitely something you should have done in Algebra 2, but sometimes you don't. Here's another one. Watch this. So instead of x squared this time, we're going to go to x cubed. Let's see how different this looks. It's got a little similarity, but it's got some difference as well. Because, remember we said, Mason. So remember, when you square something, what did I say before? If you square a negative, it's positive. You square a positive, it's positive. But when you cube something, can you get a negative? Yes, you can. All right. So let's keep that in mind. So let's do this a little faster. This is x. This is f of x. I'm not going to put some crazy big numbers because I'm cubing it. So I'm only going to go -2. All right. -2 cubed. Now I'm cubing -2. -2 times -2 times -2, which gives you what? -8. Put in a -1 in for this. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is +8. So look, this is a little different, but it's got a little bit of similarity to it. So -2, 8. So -2, and this does go to 8, so I could put it right there. I know that's 8. That's -2, 8. This is what? -1, 1.
Isn't it -2, -8?
I'm sorry. Thank you very much. It's -2, -8. You're absolutely correct. Thanks for keeping me straight. -1, -1. Okay, 0, 0. This is obviously is not a straight line now, is it? Okay, and then 1, 1. And then 2, 8. Now, what's this thing look like? It's a kind of a squiggle, all right? That's a good way to say it. So look, let's start at 0. So it comes here and it curves like this. And this comes down like that. and curves like this. So that is a x cubed function. What's the domain and range? What's the domain? How far over on the x and the y, or on the x-axis can I go? Can I go all the way over here?
No.
Sure I can, because this keeps going down, 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 and it keeps going to the left just a little bit, doesn't it?
Oh, I couldn't see that.
All right. Well, right, because like if I put a negative, if I pick this value for negative, this would be way down here like that. So I can pick any x value. What about the y values? Troy, please
They keep going.
have a little self-control. It goes to infinity. So the domain are all the real numbers, and the range this time are what? All the real numbers. So we didn't get to the third one, but here's what the third one is. If it's f of x equals the absolute value of x. Here's a little thing for you to try. I'm not giving you homework tonight, but here's what I want you to try. Shh. Settle down, please. The most immature seniors I've ever taught in my life. So look, I want you to do this. This is your homework. You're not turning it in, but just do it, okay? Just for the sake of doing it. Pick some x's, figure out what your f of x is going to be, and then graph it and see what it's going to look like on this graph, okay? So come tomorrow prepared to show me what that looks like, and then we'll do some more tomorrow.